So here we want to say, find the value f of -3. So what I want to do, this -3 then is an x value. So I'll go over here to -3 on the graph. 1, 2, 3. And I'm going to go up and see what the y value is. So 1, 2, 3, 4, 5. So it looks like f of -3 is equal to 5. Then I want to find f of 4, so I'll go over to 4 on the x-axis, 1, 2, 3, 4, and down to the function value is -6 when x is 4. For what values of x is f of x equal to 2? So for this, I want to go here at y equal 2 and see when the function is equal to 2. And so it looks like x equals -2 and x equal 1. Okay, and so the next one, for what value is f of x greater than 2? And so that looks like that just happens when x is less than -2. We have this part here where my y values are greater than 2, so all of those values. So we'll say from -6 to -2, and we'll do some open parentheses because we want it to be strictly greater than. Oh wait, -5 I mean. So hang on. The function actually stops at -5, so we'll do -5. Yeah, so there is no function past x equal -5, so all right, cool. Find the domain and range of the function. So for the domain, that's going to be all the possible x values where we have function. So it looks like starting at x equal -5, and then we have the function is defined for all those x values until we get to +4. So -5 to +4. And note that at -5, there's no function value there, so I'll do parentheses. And at +4, I have a closed dot, and so I'm going to put a bracket. And so this is the domain. And for the range, I just want to put all the possible y values that are hit by the function. And so it looks like the lowest y value that the function hits is -6, and the highest y value the function hits is +5. So -6 to +5. And it hits every y value in between there. So the next one I want to, for that function, I want to compute this rate of change. So I can do f of a plus h. That means I want to take a plus h here and plug it in for x. So let's do that. So we'll do 3 minus, and I'm going to plug in a plus h for x. And then I want to do f of a, so I need to put parentheses around this because my function has multiple terms. So we'll do 3 minus a squared. I'm going to plug in a there for, so here I'm plugging in a for x, and then over h. And now I want to simplify this. So what is a plus, let's go over here to the side. What is a plus h quantity squared? Well, that's going to be a squared plus ah plus h squared. So that's a squared plus 2ah plus h squared. And that's because when I multiply this out, I have to do a plus h in parentheses times a plus h, and then I have to FOIL it out. So, all right, so we're going to have 3 minus all of that. And then let's distribute this negative here. So when I distribute that, I'll have minus 3 plus a squared all over h. Okay, next line. Now I'm going to distribute this negative sign on all those 3. So 3 minus a squared minus 2ah minus h squared minus 3 plus a squared over h. And what I can see is that I have a minus a squared and a plus a squared, and I have a plus 3 and a minus 3. And so what's left over when I get rid of those things, so the 3 minus 3 adds to 0, and then negative a squared plus a squared adds to 0, so I have negative 2ah minus h squared, and all that's over h. Notice that I have a common factor in the top. I have an h that I can pull out. So I can pull out a h, and I'll get negative 2a minus h over h. And then here I can see that that h over h, that divides to make 1. So I'm just left with negative 2a minus h. So that's the answer to number 10. On number 11, it asks for what are the coordinates of points P and Q. And so point P has coordinates a comma b. So b comma a, excuse me. So it's the x value comma the y value. So I did it backwards there. So the b is the x value and a. So b a. And the coordinates of q is DE. Evaluate f of b. F of b is a. Solve f of x equals e for x. So when the function value is e, the x value is d. Okay. Suppose c equals f of z, and z equals f of x. What is x? So if c is f of z, that means that z is equal to 0, because when the function value is c, the x value is 0. So that is telling us, so c equals f of z tells us that z equals 0. And so then if I have z equals f of x, that means I'm solving 0 equals f of x, right? And so then I want what x value has function value 0, and that's going to be here. And so the answer is x equals h. Okay, so that one was a little, like kind of 2 steps there. First we had to look at this and figure out what z was. So if c is f of z, that tells us that z is 0. And then if I set 0 equal to f of x, I can find that the function value is 0 when x is h. Then it says, suppose that f of b is equal to negative f of d. What additional information does this give you? So if we had f of b equals negative f of d, well, what is f of b? F of b is a. So that tells us that a is equal to negative f of d, which is f of d is e. That tells us that a is equal to negative e. Okay, find the domain for each function. So if I look at number 12, this is just a polynomial function. And so there's any x value that I plug in, I'll be able to evaluate that, whether x is negative, positive, you know, a fraction or a decimal or whatever, it doesn't matter. I can evaluate, I can square any number, and I can multiply any number by 8, and I can add things up. So this is actually going to be all real numbers. So this is going to be negative infinity to infinity. So any x value I can plug in to that one. Now this one has 2 problems right here. So the first thing is that I know that I cannot have 0 in the denominator. And so that tells me that x cannot equal 1, negative 1. If x is equal to negative 1, I'll have 0 in the denominator, and that would mean my function was undefined. So I know that x cannot, so that's the first problem. The second issue here is that I have a square root, and I know that I can have no negatives under a square root. Well, really under any even root, but you can't have negatives under there. That gives you complex numbers, and we're really talking about functions that are real valued here, so we're not allowing any negatives under the square root. So what that tells me is that x plus 5 needs to be greater than or equal to 0. And so I can go ahead and solve that and subtract that over. I get x is greater than or equal to -5. So let's put these two pieces of information together and draw it on a number line. And so I know that x is greater than or equal to -5, that's here. And then I have -1 over here. And then we'll just go ahead and put 0 on there just so that we kind of have a reference. So it's not equal to -1, so I'm going to put an open circle there at -1. And it could be equal to -5. And also anything greater than -5, except we're going to still leave out -1. So we'll just plot it here on a number line. And putting it on a number line just helps you visualize. Now I can see that I have two separate intervals here. I have from -5 to -1. And I'm going to do open parentheses there on the -1 because I don't want to include that one. And then I'm going to union that with -1 to infinity. And again, I have an open parentheses there on the -1 because I'm not including that. And always we have an open parentheses on the infinity because infinity is not a real number. So.